Okay, so let's talk about the challenge of ballistic missiles. Okay, so the idea is relatively simple, right? There is place A, where there are angry little people.
Place A.
And then over here,
Somewhere between innocent civilians.
there's place B, where there are happy little people. And depending on your perspective, from modern geopolitics, you can label one of these North Korea and the other one the United States, and it does not actually matter because I think it depends on where you're sitting. Right? Because I'm absolutely certain that the North Korean version of this lecture goes, there's place A and place B, except said in Korean. And in the usual place, us, the happy, smiley people, there are these mean people across the sea who are going to launch a ballistic missile at us, right? So this lecture is symmetrical, but it occurs in Korean on the other side. Okay, so I'm going to assume that we are in fact place frowny and shooting a missile at place happy. Okay?
Okay.
That's the way I feel today.
They're jealous.
Yeah.
They're just tired.
No, we're just jerks. Like sometimes U.S. geopolitics is not that nice. Anyway, the way this works is this is a ballistic missile, which means what?
Operating in free space.
Yeah. Okay. So this is the like R3, right? You guys are all with that? I'm even giving this the distinction of assuming it's flat. Right? So let me just assume the world's flat for a moment. It won't actually change that this problem is frickin' hard. But remember that I'm assuming everything's flat. Cool? What does it mean that a ballistic missile is ballistic?
Does that mean it's turns to
Okay, so a ballistic missile means that it's governed by the laws of ballistic motion, which means that it's essentially a projectile itself that's fired, and it doesn't have an onboard guidance system and motors. So the way a modern ballistic missile works, as opposed to the way a cruise missile works, the ballistic missile is a staged rocket. So it goes up. It's got this rocket motor that accelerates it. Then at some point that acceleration cuts out, and from there onwards it's just flying. Like it's falling through the world, right? So usually the way that works is you have this like little rocket, right? Rocket. Boom. For a while in here, your rocket has a big old tail of fire, right? And then at some point up here, the fire cuts out and the tail fins and all that jazz fall off of your rocket and your missile continues, right? So if you played Kerbal or something, this phase is called boost. This event is called separation.
Or in some cases, explosion.
Yeah, or in some cases, explosion, if you screwed up your explosive bolts. And then from here on out, from here to there, that's ballistic motion. Cool? So what ballistic motion means is that it's just governed by gravity. Right? So that's me writing during that phase, A is... Yeah, so you have to know something just a titch more, which is Newton's first law. And so force is mass times acceleration.
In this case, you're not accounting for drag, right?
What's that?
You're not accounting for drag.
Yeah.
Other effects?
Yeah, no, I've skipped all of that shit. We'll put that in, and that's where it gets complicated. So the basic ideas of this are just like the acceleration vector is mass times the force vector. Right?
Okay.
Okay, well, there's only one force going on here.
Gravity.
Oh, F equals ma. Sorry. The mass times the acceleration vector is just the force. So the acceleration vector, the thing I'm interested in, is the force vector divided by the mass. If you want to account for drag and all that jazz, all that's going to do is take this force vector, and instead of thinking about that as just the gravitational vector, like my initial thought might be, well, the acceleration vector is just minus g, and I divide by m, right? And this has a, which direction does minus g point in? Down, right? So it points in the k vector direction. And I got the minus here, and then I've got my acceleration constant. That's just a constant of proportionality, right? That just tells you where you're running this thing. So like which planet you're running ballistic missiles on. And the m is just the mass of your object, right? You guys all good with this? Okay, from this, you can probably figure out a velocity vector, right? Yeah, you could integrate, right? So you should get whatever the integral of a of t is, plus, yeah, so that constant is usually the initial velocity, right? In this case, though, that velocity is a vector, right?
This is for ballistic motion, right? So the velocity should be, the initial velocity should be the velocity at the separation.
Yes! That is the velocity at the moment of separation, and in fact, our time here is probably going to be time since separation. You guys all good with that? Okay, so then to get your position function, what would you do? Yeah, you take the antiderivative of the velocity function, right, and add
Initial position, which is
yeah, your initial position, which is just going to be where it was when it separated. You guys all good with this? Okay, so let's just list challenges. Oh yeah, why am I interested in that position thing? Because what are, so this is, right, frowny people launch a rocket. Okay, what are the smiley people going to do? You guys know what the Star Wars missile defense program is about?
Hopefully they're
they're going to send a missile.
Yeah, you're going to send a missile or a laser or some damn thing to blow it up, right? That's why I'm interested in where the hell it is, because I'm going to try to blow it up. You guys got that? The easy way to do this is not easy, but you build a big machine that points some kind of a laser beam at that and heats it up until it explodes. Cool?
Do we have those?
Yeah.
Yeah, we do all the
The position was P of 0 was at separation still?
Yeah, P naught's at separation. So what you need is a position function, because you're going to feed that position function into the guidance for your laser deal, right? So it can point at the right thing. Hopefully. You guys all got this? So this is how this would work in a flat place where all I was doing was gravity, right? Pain in the ass. That's like a flat vacuum, right? Okay, so challenges I have.
Converts to triple motion.
Friction. Second challenge is actually the first challenge.
Drag.
No, the first challenge is actually knowing any of this. Like, it's not doing the Calc 3, but you need to know they launched a missile, right?
To land.
And then you need to know when it separated, how high it was, right? You need to know its mass. You need to know the initial velocity and the initial position, but those are at separation.
Yeah.
You guys see that? So your first challenge is actually the worst one, which is you have to observe the separation and launch.
And know what kind of missile it is.
Yeah.
Good luck.
Spies.
And you are going to need a shitload of good spies, because you need to know the mass. If you don't know the mass, all you can do is ballpark it, right? So you get a couple observations and try to guess. But keep in mind, if this is for real, that thing's a nuclear weapon, right? You don't have time to frigging guess. Also, you're trying to point a laser beam at this thing, right? If you're off by 2.5 meters, is it going to work?
No.
Probably not.
A laser plane.
That's actually a thing. Like, to make more of a shotgun and less of a... So when we talk about launching a missile to intercept this thing, those are more of a shotgun and less of a laser beam. Because you already screwed up with the laser beam. Right? So this is super hard. Right? Then you have to do a little Calc 3, which is not so bad. You have to account for friction, which amounts here. Instead of thinking, okay, the acceleration is just minus the gravity over the mass times up, right? You have to do, well, this is a vector sum of friction, or of forces, right? So you do, okay, well, there's a force due to gravity, which I make as some vector, right? And then there's some other force due to drag, which I call d and add as a vector.
Why would gravity be a vector if gravity is constant? I don't really see how.
Yeah, so really that's because I need this equation to have the same category on both sides. Gravity's constant, the direction in which it points is also kind of constantly down, right? But that's me doing this on a flat plane, right? If I do this in the world, the direction gravity points is towards the middle of the planet. For this thing to go from place A to place B that are around the planet from one another, it's going to matter that that thing's not actually down, right? I mean, it is down, but down means something else depending on where you are. You guys see that? Okay, so in addition to friction, observing the separation and the launch, what other problems do I have? Yeah. Yeah, so there's like friction and then some.
Special relativity.
You got to take into account a bunch of stuff. You have to actually build a laser.
Yeah.
Oh, well.
Cloud cover could be problematic.
Yeah, the density of the atmosphere changes constantly.
Yeah, actually, this is a bad one. So bending of laser?
Yeah.
Not like bending of the apparatus, but as you fire this thing, right? For a while it's going through air that's a certain temperature and density. And then it hits another layer of air that's a different temperature and density. And then it hits another layer that's another different temperature and density. And so it does this, like, it doesn't go in a straight line. It does this, like jig, jog. Well, it probably doesn't go backwards.
Something's wrong
But
with
it
our
does something
atmosphere
like
if that
this,
happens.
right?
Some for the mirror.
You guys with me on that?
Atmospheric error.
Okay. What other challenges do you see?
Birds.
Yeah, what if they put stuff in the way? What if they're at separation it sheds 3 things instead of 1 thing?
Oh yeah, the decoys.
What if it sheds, I don't know, like just a bunch of crap? Like, what if it has just a layer on the outside that explodes into 1,000 pieces that are all the size of a dinner plate? This stuff's all going according to ballistic motion, right?
Yeah.
It doesn't need a drive or anything. That shit's all just thrown up in the air. If you throw a pile of pebbles, right, they stay more or less together for a while. You're trying to shoot a laser beam at this thing and it's got a bunch of dinner plate sized crap hanging out around it. You gotta vaporize all the dinner plate sized stuff before you can get to this thing. You guys see that? Okay, well there's a challenge for you. Then there's the biggest challenge that I haven't highlighted here is what? What have I missed?
Earth rotates.
Yeah,
So
that's that friction and then some stuff. Like you can figure that out. That's what physicists are for. But what's the other weapons system thing here? What did I make? I made an assumption that's really stupid nowadays. It was a good assumption in the 60s.
that the acceleration.
That they only launched 1?
Yeah, okay, so I assume they only launched 1. That's probably a shitty assumption. Worse yet,
Does the laser even affect the missile?
That is simple conservation of energy, thank God. I could dump energy into it and it'll melt eventually.
That's ballistic?
Yeah, I assume the friggin' thing was a ballistic missile. Right? And not some kind of cruise missile? Not some kind of thing with a couple of little thrusters on it?
That'd be spies.
Yeah, that's why you have spies.
That would be good for spies, right? So even if I know that it jig jogs a little bit, right? What if it just has a couple of random, like, psh, psh, like little thruster fires during its course? What if they're not even known to the programmers? Like, what if they're actually random evasive actions? You guys see that?
Oh, jeez.
Like, if after it separates, it waits a bit, and then, like, it waits a random number of minutes or seconds, and it goes, random thruster fire for random seconds. Right? Then where the hell is it? I don't know.
Did you figure out when they generate the pseudo-random number?
Make it easier to track than just like a big hunk of metal flying through
So
the air.
Maybe. I don't know how much guts it has to have. It doesn't have to broadcast anything.
So basically, wouldn't that mean that if you were going to counteract this non-ballistic missile with a ballistic missile, then it must basically get there instantaneously? Or the only way to counteract a non-ballistic missile is with another non-ballistic missile, in which it's updating with data, so it actually gets the right location.
Yeah, that's a fair point. So one of the reasonable things to do with this would be to be like, oh, screw it, we'll wait till it's close and then we'll shoot a bunch of stuff that can chase it. Right, but you gotta remember, this thing's coming down at basically the speed it went up. It's coming down like a frickin' rocket. So you can't, like, if you miss, you don't get to turn around and catch up. Like, that ain't gonna be a thing. You guys see that?
Uh-huh.
So this is why the Star Wars Missile Defense Program doesn't work. It just doesn't work. It's not gonna work. It's too friggin' complicated.
That's why you have to.
You're not gonna get 100% of 1,000 missiles. It's just never gonna happen.
That's why you have to detonate the enemy missiles in their silos.
This is the argument for preemptive strike, actually. Because you gotta blow them up before they get off the ground, because you can't stop them. Right? Which is a friggin' shitty argument, frankly. Anyway, this is the argument for not having nuclear weapons. I think it's maybe the more rational approach, other than blow them all up. Because the other guy's thinking that too, right? So you got to play this game theory like, are they about to launch their missiles? Because if they are, I'm going to launch mine. So what, do you guys know the Cold War end of this discussion? Because we already did this once. This wasn't had with the U.S. and North Korea. This was had with the U.S. and Russia.
Mutually assured destruction is society.
Yeah.
Yeah, so the idea behind mutually assured destruction is not they won't do it. It's if they do it, there'll be radioactive gas too. Which actually deters most people, as it turns out. Like, don't launch nuclear weapons at us. We'll nuke you back. Everybody will be dead. It'll really suck. But you have to have people who understand, if I do this, then they'll blow me up. And that's a two-step thought. It concerns me.
That's why you can do it.